here for about 15 minutes. 15 minutes. All right, let's take a look. What's neat about this is when you do dilutions, and when I do one for the school, I simply get this equation out. It says the first molarity times the first volume has to equal the second molarity times the second volume. So what you want to do is you want to scan this and look, and you said, if I add 25 milliliters to blah, 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 blah. So what did I start with? I started with 125 milliliters, and what was the concentration? 0.15 molar. So I put, that's the first molarity, that's the first volume. That has to equal the second molarity, and we don't know what that is because what will the molarity be? We don't know. So that's your X. If you like to put X like in math class, that's solving for X. But what's your second volume going to be? Be careful. It's not 25. What is it? It's 25 plus 125, isn't it? So really, you say, I think I can do these problems. Because watch, you say this times this divided by that, and you're done. It's this times this divided by that. And here's what's easy about it. Watch. Guess what cancels on both sides? Milliliters. So what's the only label left is big M. Big M is molarity, isn't it? And this is our answer right there. Are you okay on that? All right, I'm going to move on. That's dilution. Okay, that's the dilution problem. Okay. Just keep it. All right, here we go. Now, this right here, this one is a little bit harder. It's just a little bit harder, but we're going to do at least two of those before we get into this, and then you guys will start some practice. All right, let's take a look at this. Now, neutralization, I don't know if you've ever known this, but there are people that, young people, definitely older people, sometimes they have problems in their stomach. And sometimes your stomach, especially if you're under a lot of stress, it'll tend to make more acid. I don't know if you knew that your body made hydrochloric acid. It makes acid. And if you're under stress, sometimes it makes more acid than it should. It's supposed to wait until food gets down there, and then it senses there's food in there, and it makes a certain amount of acid, and everything's okay. But some people make more acid than they should, and then sometimes that acid comes up there. You'll feel it up here, and they say heartburn, but it really has nothing to do with the heart. It's this acid burning up here in your food tube, your esophagus. And do you know anybody who has acid reflux, or you never heard of this? Okay. I know several people that have it. My brother-in-law, he has to elevate his bed like that. When he goes to bed, it has to be like that, because if he lays flat, the acid, it's just, and he's been to a couple of doctors, they just can't seem to figure it out. So he just has to elevate his bed so he's not laying flat. Now, if you just have mild cases of this, they have things like Tums or Mylanta. Well, if you look on the package, it says, Tums will say contains calcium hydroxide or magnesium hydroxide, like Mylanta. And so what I'm going to do is, why? Those are called bases. And when you stick a base in an acid, they neutralize each other. So that's what's called neutralization. If I were a first responder and I knew that there was an acid spill at some factory, maybe some people, the fumes got to them, we had to take them to the hospital, but we had to get rid of that acid. I would throw some base. I would try to go get some base and put it on there, and that would neutralize the acid. So have you ever heard of this before? Acids neutralize bases and vice versa? Yeah. Okay, so watch right here. When we're doing neutralization problems, take a look here. I'll show you the equation. The molarity of the acid times the volume of the acid equals the molarity of the base times the volume of the base. Now, the only thing that makes it looks very much like the one we just did, didn't it? Okay, the only thing that's different here is this is a real chemical reaction. When I dilute things, that's not a chemical, that's a physical change. It's not a chemical change. Okay, now this is where I need your attention, okay? So I need your attention. The only thing that's hard about this is this right here. When it says the molarity of the acid, what they really mean is the molarity of the ion that made you an acid. So I want you to put that there, the little hydrogen plus one. And in this, when I say the molarity of the base, they really mean the molarity of the ion that made you a base. Now, the only reason I need to tell you that is sometimes it doesn't matter, but let me take a look here. Let's do this problem here. What volume of 0.075 molar HCl, do you recognize that as an acid? Does everybody know that HCl is the world's most famous, what is that called? Hydrochloric acid, right? Now, so that right there, here's where I need your attention, all right, ready? What's the molarity of HCl? It's that number there. But what's the molarity of just this hydrogen ion? Well, here's how you do it. For every one of these, how many hydrogens do you get? So 1 times that is, so I get to use that number. So what's the molarity of the acid? What's the molarity of the ion? 0.075 molar. All right, one more. What volume of that? We don't know. That's my X. And here we go. This is the tricky part. This is the tricky part. If you can stay for 30 seconds. Ready? How many hydroxides are in this compound? For every one of these, how many hydroxides do you get? 2. Uh-oh. So the concentration of this chemical is 0.01, but what's the concentration of the hydroxide ion? 0.02. So I had to multiply this times 2. That's the only thing that makes this hard. And what is the volume?
Does that say square root of G?
No, this is calcium hydroxide. Square root.
What is that after the 0.75 L?
Oh, this is a volume of the acid. There, that's what you thought. Okay, here we go. And then we put 100 milliliters here, and watch what happens. Big M cancels, and what are you going to do here? It's this times this divided by that. Everybody do that. This times this divided by that. And if you have to go ahead and go. Anyway, go ahead and put that in there, and let's see what you get. Yes?
What's the letters after the M and the B on the right side?
This right here?
No.
Up here? Okay, so this chemical here is calcium hydroxide. Now, the only thing that's tricky about this is that what ion made you a base? The calcium ion or the hydroxide ion? And it's the hydroxide ion. See that? So watch now. If you had a certain number of these, how many of these would you have? You'd have twice as many. So if the concentration of this chemical is 0.01, what's the concentration of hydroxide? It'd be twice as much. That's the only trick about this. So get it? And after you do about 2 of these or 3, you say, no problem, no problem.
No problem.
So let's try it right now. Everybody put this times this, divide by that, and tell me what the answer is.
It's 6.7. What's the word?
What now?
What's that word? What is the word?
This word? This one. Which word?
A little bit slow.
Up under OH.
The one that says
No. Yeah. No. What are those words?
Oh, okay. Base. That's the word base. Okay. All right.
That took for
Yeah, base.
base.
Okay, now,
26.6.
what is it?
26.7.
Hey, would everybody do that and let's see what happens?
26.7.
Would everybody try that and see if we get this? So this times this would be 2. 2 divided by 0.075, that'd be a pretty big number. And you're saying it's 26.7? Did everybody get that?
Yeah.
This times this divided by that. All right. Now, what I'm going to do here, watch now. When we do the second, can everybody raise their hand if you got 26.7?
Yup.
Okay, that's looking very good. That's looking very good then. Now, take a look at the second one. By the time we get this one done, everybody should say, and this is my last lesson. This is about it. So take a look at this. Do you recognize that that's the acid? Acids always start with H, don't they? Is that right? Okay, so
Start with 8.
how many hydrogen ions are in this acid?
Oh,
0.01.
No. How many? Just look at this chemical. 1.
Oh, 1.
So I get to take 1 times that, so the molarity of the hydrogen ion is that number. Now, what's the second chemical? NaOH. For how many OHs are in that?
1.
Okay, so I don't have to worry about multiplying by anything. I get to use that number there, don't I?
Yep.
All right, so what's the acid-base neutralization equation? Is what? Ma, what's that stand for? The molarity of the acid times the volume of the what? Acid. Has to equal the molarity of the base times the base. Now, go searching and see what kind of numbers go where. Who goes where? Let me call on somebody. Taylor. See this number here? Where do you think that would be? It goes here, 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 or here? It is. This is the molarity. Big M is molarity, isn't it?
Yeah.
0.115 big M. Now, what's the volume of the acid? Well, they're not going to tell us, are they? Okay, J3, what do you think this number is? The 50. Is it this
Not a
or
50,
this?
The 50 base.
it's the ball.
Which one?
50 the base. The first one.
It is volume. It is volume. Now, so we put it right here, and we go ahead and put it second. We don't have to put it second, but that's where we can do that.
Take advantage.
And now, the last one, and I don't know, whoever printed this, they should have put the big M here so you don't lose track, but that is the concentration of the base, isn't it? So that's the molarity of the base, 0.0875. Okay, now, how do we do this again? And this is big M. Okay, so this times this divided by that. All right, let's go ahead. Everybody do it. So we go this times this. What is it?
Ben, bro.
Ben, actually, before.
I meant 30. You meant 38.
What do you have?
32,608.
So about 38
Yeah.
milliliters.
Yeah, 38.
All right, everybody try it and see if you get 38.
That's what I got.
All right. What do you think? Okay, so the rest of this is just kind of like a little review. Let's go ahead and do this. Go down here, and here's some vocabulary words. And some of these, there might be one you haven't had, but let's see if we can match these. Who wants to try number 12? Who thinks that they think they figured out? Read it and tell me which one you think the answer is. Go ahead. 12. So the substance, go ahead and read. Say the substance dissolved in a given solution. What's it called? Solvent. What do you think? How many people agree?
No, I'm just playing with you.
Okay.
Saw you.
Solute. How many people think that's right? Right. The solute is the stuff that gets dissolved, so you're right. So let's find solute. That's E. You can actually write the word solute or you can put E here. All right, who wants to try the second one? These are vocabulary words.
You got it.
What do you think? Who wants to try it? Yes, Gabe.
Mass percent.
Yes. Expresses the mass of the solute per mass of solution, and it's called percent by mass. And the book calls it mass percent. I call it percent by mass. It's the same thing. Very good. Next one. Hayden.
Saturated.
Okay, can you read it for me?
A solution contains as much solute as will dissolve at 10%.
If it contains as much as it could, it's called what?
Saturated.
Yes. Man, you guys are good at that. That's C. Who wants to try the next one? All right, go ahead, Sean.
Most commonly used expression of concentration describes the amount of solute in moles and the volume of the solution in liters, and that's morality.
Now, okay, wait a minute. We're okay, wait. Okay, all right. So wait, you're paying attention. You must have, your humanities teachers must be talking about morality. Or maybe your pastor is talking about morality, but I think you mean, yeah, yes, that's it. I think you mean molarity.
Yeah.
That's good. Thanks. My wife always asks me, well, tell me something funny you had in school, and a lot of times I can't tell them, but I won't use your name, but that was funny. I like that. Okay. All right, so where is molarity?
Can't beat
Ace. That's good, though. Thanks. That made me laugh. All right, let's do the next one.
I got it.
Yes.
Acid-based reaction. Neutralization.
Yes. Very good.
That is all that.
All right, next one. This one's a short answer. Molarity equals something over something. So who wants to try that? And you already answered two, so I'm gonna wait. Somebody else. J3.
Oh, yeah, man.
Okay, now you gotta say moles of what? Hey, listen.
That was Matt, right?
Okay.
I did not even,
Hey, I mean it. Stop.
I didn't even do that.
Okay, moles of solute J3 what over what?
Whoa.
Moles of solid over what?
Leaders. Yeah.
Liters of solution. Isn't that right? Okay. All right, next one, the dilution equation. Who wants to try that? Somebody hadn't done one yet? Anybody? He did one. All right, yes, Riley. Shh. Hey, hang on. All right, go ahead. Yes.
Good job, brother.
Okay.
Thank you, Ben.
Okay. Number 19.
You're welcome.
Let's try that.
Matt ain't done one yet.
Okay. All right, he can do it. I bet he can do it. Watch.
Let's go back. We can do it.
Na times Ca equals NaB VAB equals. It's the wait. What is the question asking? It's the equation for.
I'll give you a clue.
The neutralization.
Yes.
Well done.
You could probably skip the next one. If I do put it on the test, it'd be an extra credit question. If you remember here, I told you the only thing I really don't like about concentration is there's so many units. There was actually one that's used, they used it before molarity, and it was called molality. And there it is right there. There's a definition. So I don't worry about that's the one. I won't use this one, but I'll put it down anyway. It's called molality. But anyway, if you want to just kind of cross that out, I won't be able to do that. I won't be doing that. Okay. Now, if you look right here, the last page, we don't take the test until, it might even be Wednesday now because I forgot about Friday being a half day. But these are all the equations you might use. Now, take a look at the first one. Percent by mass or percent by volume. We did those problems. Molarity. Take the same equation, rearrange it. What's molarity times volume in liters? It's moles of solute. It's the same equation. This one. Here, I told you one of the hardest things in this whole chapter was this. If you know the concentration of that, what's the concentration of calcium ions here? Look one more time. If the concentration of that chemical is 0.5 molar, what's the concentration of calcium ions? There's only one of them there, isn't it? There's only one of them there, isn't it? For every one of these, you only get one of those, so it'd be 0.5 molar. And what about the concentration of chloride ions? For every one of these, there are two, so it has to be twice the size. You're right. And I told you that was the hardest part of the whole chapter. Next, the dilution equation. We did it yesterday and today. And today we did the acid-base neutralization equation. That's it. And then the vocabulary words, right?
We use this on the quiz.
Okay. What now?
We're allowed to use this on the quiz.
For sure.
I don't know about that. Okay, so now, what I'm going to do, hold on.
Don't let us, I'm gonna leave
Wait.
it there,
What I'm going to do, hey, hold up. Shh. Wait a minute.
Yeah, we ain't had one of them all year.
Open
I'll think about it.
Oh, no. The pressure's on you.
Okay, hang on. I'm going to turn this off.